Assalamu alaikum warahmatullahi wabarakatuh. Our today's lesson here about matrix operations and their applications for our curricula, which is pre-calculus for grade 11. So today's lesson, gonna learn how to use matrix notation, how to use how to understand what it means by equal matrices, add and subtract matrices, perform scalar multiplications, solve matrix equations, multiply matrices, model applied situations with matrix operation. Okay, today's lesson about matrix operation. Let's start. Here we have to know that every matrix contains rows and columns. I here instead of any row, J instead of the column. So A, I, J means an element in its position, which is in order I for row and J for column. So the matrix contains m rows and n columns. The matrix, we can write it as m times n. If the matrix contains 3 rows and 4 columns, so we're going to call it matrix 3 times 4. 3 times what? 4. Again, what it means by an element A32. This element in the position, the third row and the second column. The third row and the second column. Let's see. What is the order of A? First of all, you know that the word order here, write the matrix. The matrix order is m times n. M here, number of rows, 1, 2. And n here is the number of columns, 1, 2, 3. So this matrix is 2 times 3 order. 2 rows and 3 columns, 2 times 3. Where is the position for A23? The element A23 is a number or a member or an element which is in the second row and the third column. The second row here, third column. So A23 is negative 1 over 5. Where is A12? A12, yes, bravo. First row, second column. First row, second column. So 2 is the member A12. Again, this matrix order is 2 times 3. A23 is the number negative 1 over 5. A12 is the number 2. Let's start again. In this matrix, what is the order of this matrix A? The order is m times n. Number of rows into the number of columns. Let's see. Rows 1, 2, 3, 3. Rows, columns 1, 2, 2. The order of A is 3 times 2. Identify A12, the member, the element in the first, yes, row, and, thank you very much, second column. First row, second column. First row, second column. Here is negative 2. A31. Third row, first column. Third row, first column, which is 1. Where is A2, 2, second row, second column? Yes, thank you very much. The number pi. Equality of matrices. We can say that the two matrices are equal if their orders m into n is the same. So, for example, The matrix which is contain X, Y plus 1, Z, and 6, 4 members, is equal to the matrix 1, 5, 3, 6. It means that the first number here, or first member, X, must be equals 1. Y plus 1 is the same 5. It means like Y equals 4. 6 here is the same 6, thanks. But Z in the left hand side is the same 3 in the other hand side. Thank you very much. We already learned it, how it means by the word equality. How to add and subtract. If you want to add, add the same member, the same line, the same row, and the same column to each others. That means like if you want to add two matrices, they must have the same order. So this matrix is 2 by 2, and this matrix is 2 by 2. So we can add them. If they have different orders, so it's impossible to add. So let's start how to add. We're going to add first and first, 1 and negative 1, which is 0. Negative 2 and 6, which is 4. 3 and 0, which is 3. 5 and 4, which is 9. We have finished our work, you know. The same thing with subtraction. If you want to subtract two matrices, so the orders is the same, 2 by 2 and 2 by 2. Thank you very much. And now 1 minus negative 1, 2. Negative 2 minus 6, negative 8. 3 minus 0, 3. 5 minus 4, 1. So we have finished our work. Can we add these two matrices? No, we cannot. Because the first matrix has an order 2 by 2, but the second matrix has an order 3 rows and 2 columns. So they are not equal order, so we cannot add or subtract them. Thank you very much. And now, how to add and subtract. Add here A plus B, the first matrix and the second matrix, and then subtract these two matrices. So are these two matrices same order? Yes. Both contains 2 rows and 3 columns. 2 rows and 3 columns, both. So we can add them. We're going to add 0 to negative 2. 0 to negative 2. 0 plus negative 2 is negative 2. 5 and 3. 5 and 3 is 8. 3 and 5. 3 and 5 is 8. Negative 2 and 7. Negative 2 and 7 is 5. 6 plus negative 9, and so on. Negative 8 and 6. If you want to subtract, they have the same order. Let's start. Negative 6 minus negative 5, which is negative 6 plus 5, negative 1. 7 minus 6, 1. 2 minus 0, 2. Negative 3 minus negative 4, 1. So we have finished our work. Finally, if you're going to add a matrix to the 0 matrix, the 0 matrix here, a matrix contains all elements are 0. So don't forget they have the same order. If you're going to add A to 0 becomes A. So 0 is called an identity. The 0 matrix called an identity matrix. So the identity, the additive identity, means a matrix that we're going to add to any matrix becomes the same original matrix. So can we know whether the two matrices additive inverse to each other? What it means by the word additive inverse? The word additive inverse means if we're gonna add the first matrix to the second matrix, they become zero matrix. So let's start here. If we add these two matrices, first, 0, second, 0, la 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 0, blah 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 0. So if these two matrices have a sum of 0 matrix, we're gonna call each other an additive inverse to the other, cause their summation contain or obtain an additive identity matrix, which is called 0 matrix. Okay. And now, if you wanna multiply a scalar multiplication, a number, scalar value, we're gonna multiply it to the matrix, which is contain whatever the number of elements. So if you want to multiply a number, you're gonna use the distributive property. You have to multiply it to each member in the matrix. So 4 into 2, 5, and negative 3, 0. We're gonna multiply 4 by 2 first, which is 8. 4 by 5, 20. 4 by negative 3, negative 12. 4 by 0, 0. So if you want to multiply a scalar into a matrix, we're gonna multiply this scalar into any element or each element in this matrix. How to multiply negative 5b? Negative 5b, there is b here. So negative 5 into the matrix B, we're gonna multiply negative 5 in each member. For each member here, it becomes negative 5 by 2, negative 10, negative 5 by negative 3, 15, negative 5 by 5, and negative 5 by negative 6. So we have another matrix, negative 5 times the first matrix. How to determine 2a plus 3b? So we have three missions. The first mission is to double A. The second mission is to triple B. The third mission is to add in the first previous lesson. So 2a. Multiply 2 to each number here. Becomes 2 by negative 1, negative 2. 2 by 4, 8. 2 by 3, 6. 2 by 0, 0. Again, 3b. 3 times b. 3 times 2, 6. 3 times negative 3, and so on. 3 times 5, 3 times negative 6. If you want to add, alhamdulillah, they have the same order, 2 by 2. So add the first element, negative 6 and negative 2 and 6. 8 and negative 9. 6 and 15. 0 and negative 18. Becomes negative 2 and 6 is 4. 8 and negative 9 is negative 1. 6 and 15 is 21. 0 and negative 18 is negative 18. So it's very easy lesson. We learn it how to add, subtract, how to determine the scalar number into any matrix we want. Solving a matrix equation. Solving a matrix equation, we're gonna solve for x in the matrix equation. If we have 2x, x here is a matrix, plus a here is a matrix, becomes a b. We have a, this is square matrix, we're gonna call it كلمة squared, the word squared for a matrix which is contain the same rows and the same columns. 2 times 2. Here is about 2 by 2, which is like square matrix. Okay. How to determine x? We're going to solve for x. Okay, mister. We want a matrix. We multiplied it by 2 and add it to the matrix A becomes a matrix B. So we can do the same thing. We already learned it before in grade 7, how to solve an equation. I think first step we have to subtract the A from both sides. So let's start, find B minus A. And then divide the main matrix, the resultant matrix, by 2 or multiply by half. Let's see how to determine the new matrix X. First of all, subtract B minus A. B minus A, B here, minus A. Negative 6 minus 1, 5 minus negative 5. 10, 9 minus 0, 9. 1 minus 2, negative 1. Multiply all by half, which is mean divide by 2. So negative 7 by half, negative 7 over 2. 10 by half, 5. 9 by half, 9 over 2. And negative 1 by half, negative half. So that is the matrix X. How to determine X here? First of all, find B minus A. Hurry up. B minus A. Negative 10 minus 2, negative 12. 1 minus negative 8, 9. Negative 9 minus 0, negative 9. 17 minus 4, 13. And then divide all by what? 3. Divide by what? 3 becomes negative 12 times third, negative 4. 9 into third, 3. Negative 9 into third, negative 3. 13 into third, 13 over 3. So we have finished. And now, how to multiply matrices. How to multiply two matrices. Okay. It's very easy to multiply two matrices, but pay attention, please. If we have two square matrices, each one contains 2 rows and 2 columns. The first matrix contains members whatever A, B, C, D, and the other matrix contains members E, F, G, H. If you want to multiply, please, we're going to multiply the first row by the first column. How come? Yes. The first row here is AB. The first row here is AB. Okay? And the second and the first column here is EG. We're going to multiply AB into EG. A times E plus B times G. Again? Yes. We're going to multiply the first times the first plus the second times the second. A times E plus B times G. That is the first member in the resultant matrix after multiplication. So the second one to the right, it means like we're gonna multiply AB into EH. A times F, AB times FH. AB times FH, which is AF plus GH. Again, which is AF plus BH. So the third member, if we multiply CD into EG, becomes C times E plus D times G. C times E plus D times G. Fourth means CD and GH. C times F, CD and FH. CD and FH. C times F plus D times H. Okay, we're gonna multiply the first row times the first column. The first row times the second column. Then the second row times the first column. The second row times the second column. Let's see again. This matrix contains AB and this matrix contains EG. If you want to multiply, multiply AB times EG. A times E plus B times G. It's the simple one. How to multiply A, which is 2347, and B, which is 0156. Let's see. We will perform a row by a column combination or computation. Let's see. We're going to multiply the first row into the first column in this criteria. 2, 3 into 5, 0. 2 by 0 plus 3 by 5. Is it hard? 2 by 0 plus 3 by 5. This is the first element in the resultant one. 2 by 0 is 0, 3 by 5, 15. 15 plus 0 is 15. That's the first one. The second element. The first row into the second column. 2 by, excellent, 1 plus 3 by 6. 2 by 1 plus 3 by 6, which is 18 and 2, 20. The third element, we're going to combine 4, 7, and 0, 5. 4 by 0 and 7 by 5. Row into column. Row into column. First plus second. The last one. First, second row in second column. 4 by 1, 7 by 6, which is 46. Let's see again. Let's see it again. How to multiply A by B? If you want to multiply A by B, first, multiply the first row into the first column. Hurry up. 1 by 4 plus 3 by 1. Again. Let's see here. A small font. Another color. Okay. The first row and first column. Hurry up. 1 by 4 plus 3 by 1. Hurry up. The second member is first row and second column. First row and second column. 1 by 6 plus 3 by 0. For this member, second row, first column. 2 by 4 plus 5 by 1. If you want to multiply the last and obtain the last member, please multiply the second row and the second column. 2 by 6 and 5 by 0. Now we have a matrix which is 1 by 4, 4 plus 3 by 1, 3, which is 7. 6 plus 0, 6. 8 plus 5, 13. 12 plus 0, 12. Now we already multiply A into B to determine the product and the resultant matrix. we cannot, we cannot, we cannot. Here is the first important part. We cannot multiply any two matrices. You know, if the first matrix is m by n, m rows and n columns, and the second matrix n rows into مثلا blah 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 b columns, these two numbers here identicate evidence that we can multiply the two matrices or not. Yes, yes, we can multiply some matrices, we cannot multiply another product matrices. The main evidence, the main proof, the main criteria to multiply the two matrices, that the first matrix number of columns must be equals the second matrix number of rows. Okay, and we can imagine that the resultant becomes m rows and p columns. Let's see how and why. And again, if we have a matrix 3 by 4 and the other matrix 4 by 2, what it means 3 by 4? A matrix contains 3 rows and 4 columns. B is the matrix contains 4 rows and 2 columns. Can we multiply them? Just we're gonna say yes or no. Yes or what? No. Let's see if it's yes or no. Let's see whether it's yes or no. The first matrix contains 3 rows and 4 columns. The second matrix contains 4 rows and 2 columns. The inner part, which is the first number of columns and the second number of rows, are they the same? Yes, they are 4. So we're gonna say yes. We can find A times B. And we can imagine before multiplication, before working, that the resultant matrix and the product between them becomes a matrix 3 rows and 2 columns. Understand? Again, can we multiply these two matrices? The first matrix is 2 rows and 3 columns. The second matrix also 2 rows and 3 columns. Can you multiply them? Let's see. Can you see here the inner part? The first matrix columns are 3. The second matrix rows are 2. So we cannot multiply them. And put your pen, do work, don't do anything. Mister, I can't multiply them. You know, mister, the first matrix columns contain 3 columns. The first matrix contains 3 columns. And the second matrix contains 2 rows. You said, if you want to multiply 2 matrices, you have to see, you have to observe while viewing, before working, that the first matrix columns must be equals the second matrix rows, number of rows. So we cannot multiply here these two matrices. Understand? Can you multiply A into B? The first matrix contains 2 rows and 1 column, but the second matrix contains 1 row and 2 columns. Can you multiply them? Yes, yes, mister. You see, these two numbers are the same. And we can obtain a matrix after product AB, which is contained 2 rows and 2 columns. Thank you very much. Here, Can you multiply the matrix A, which is contains, yes, one row and 3 columns, into the matrix B, which is contain 3 rows and 1 column? Yes, yes, we can, because they have the inner dimension of the same, and we can obtain a matrix contains 1 row and 1 column. Let's see how. 1 row and 1 column. We're gonna multiply 2 by 1. We're gonna multiply. First step already, we know that we can determine the product. And now we're gonna multiply the first row by the first column, which is 2 by 1 plus 0 by 3 plus 4 by 7. It contains 1 element. 2 by 1, 2 plus 3 by 0 is 0. 4 by 7 is 28. 28 and 2, which is 30. The resultant matrix contains one member, which is 1 column and 1 row. 1 column, 1 row. Okay, because the first matrix A contains 3, yes, bravo, 1 row, 3 columns, but the second matrix contains 3 rows and 1 column. This evidence here to multiply them well, and this is evidence for the resultant, which is contained 1 member, which is 30 now. Can we multiply these 2 matrices? Where possible, find each product. Where possible, find each product. Means if it's impossible, don't work. Don't do anything. Okay, mister. In letter A, the first matrix contains 2 rows and 2 columns, 2 by 2. The second matrix, 2 rows and 4 columns. 1, 2, 3, 4 columns. Again, 2 rows and 4 columns. Mister, yes we can, the inner dimension here is 2 and 2. And we know that the resultant becomes a matrix, the resultant A times B becomes a matrix 2 by 4. Let's see how to multiply them. How to multiply them. Yes, mister. First row into first column. 4 by 1 and 2 by 0, which is 4. First row, second column. 4 by 2, 2 by 2. 8 plus 2, 12. First row, third column. 4 by 3, 2 by negative 1. 10. First row, fourth column. 4 by 4, 2 by 6. 4 by 4, 2 by 6. Here, second row, first column. 1 by 1, 3 by 0. 1 by 1, 3 by 0. First row, second column. 1 by 2, 3 by 2. 1 by 2, 3 by 2. 2 plus 6, which is here 8. First row, third column. 1 by 3, 3 by negative 1. First row, last column. 1 by 4, 3 by 6. 1 by 4, 3 by 6. 4 and 18, 22. So we have finished. Is it hard? Let's see the second one. The second one. Here we have how many rows? 1, 2 rows. Times how many columns? 1, 2, 3, 4. How many rows here? 2. How many columns? Hurry up, please. Okay. Here is 2 rows and 4 columns. Here is 2 rows and 2 columns. So we cannot multiply them. Understand? Understand why we cannot multiply these 2 matrices? Because the inner dimension are not the same. Let's see here how to multiply. So we're gonna say just if you wanna multiply or not, if you can multiply or not. Here the first matrix is 2 by 2. The second matrix, 2 rows and 1, 2, 3, 4. Yes or no? Say yes. After that you can multiply. How many rows here? 2 rows by 4 columns. Here is 2 by 2. So we cannot say no. Can you obtain, like, can you prove something here? Can you imagine something here? Can you like observe something here? Yes, we can observe something. This matrix called A masalan, like, and here is B, here is B into A, right or wrong, the same matrices. It means like AB must be equals BA, the commutative property. No, it's wrong. Sometimes AB can obtain and BE cannot obtain already. Understand? So till now I can say thanks for you, but please, is the associative property allowed in matrices? Is the distributive property allowed in the matrices? Is the scalar number as associative property allowed in the matrix? Yes, but the commutative property, which is replace the position of each matrix, is not allowed. Inshallah Rabbil Alameen. Next, inshallah, we're going to learn the applications on matrices. But now I have to say bye-bye. Assalamu alaikum wa rahmatullahi wa barakatuh. I hope to understand this lesson well. Please call me for any explanation. Assalamu alaikum wa rahmatullahi wa barakatuh.